Okay, so we've looked at several cases. We've looked at the sunny day case, where you've got a cell that's completely surrounded by other cells. We've looked at the edge cases. We looked at the top edge and the bottom edge. The right and the left are similar. Remember, the corners are sort of special cases where, take the top left corner, for example. It can be both a top edge and left edge. So they're very similar to what I showed you for top and bottom. So let's talk just for a minute about possible program structure. So you want your program to be multi-threaded. We want to have one thread where the game engine runs and one thread that is the UI thread, the user interface thread. We want our user interfaces to be very responsive. When the user clicks, we want to give them an instant response. And even if the response is, we're busy, we can't do what you want right now, that's a response. That's infinitely better than no response at all. The users have a pretty short attention span. They'll think your application is hung. They'll think it's broken. So we want to have at least two threads here, and we could manage these threads ourselves using some of the basic tools from the Java programming language. But I recommend that you use the framework provided by Android, and that's this async task framework. And this this is a powerful framework. It does have its limitations, but for what we're trying to do here, it's absolutely adequate in every way for what we want to do. And you could do something like this. So recall we had the params, the progress, and the result. Params, progress, and result. So here's a suggested way to go. You can create a class of your own and have that be one of the types in this templatized class. And recall, there's many examples where you're using strings and integers and that kind of thing, which is fine. But there's no reason at all that you can't use a more complex data type. Part of the beauty of object-oriented program, part of the beauty of classes and objects. So here, this life params, you can actually create your own class, and you can populate it with members that are different game characteristics: number of rows, number of columns, generation time, pattern, things like that. And you can have methods. You can have so-called getters and setters to set these parameters with the setters and to retrieve to get with the getters. So that's a pretty handy thing. That's the parameters. The progress, the way we're going to try this in our do in background method, in our worker thread that we spin off, we're going to run a generation of the game, and we're going to report out the progress after each generation. The progress is realized in a 2D array. Now, I used a 2D array of character for historic reasons. In my examples, I use a asterisk character to represent a cell as alive, and just a blank, or the absence of any character at all, to indicate that the cell is dead. For the results, I just have class object here. Object is the top of the inheritance hierarchy in Java. All classes inherit from object. Truth be told, we don't really need it in this suggested structure, because we're going to report the results in publish progress, which is this 2D array of char. We're going to report these results after each generation of the game. This object, it could be used when you're quitting the game, when you're ending the worker thread. You could use it to pass out a message or something. thanks for playing, end of game, something like that. So we don't really need it. We're going to update the game of life results for each generation via published progress. So let me share with you a code snippet. Bring up Eclipse here. There it is. Okay. So here is a piece of this async task. It's just a skeleton. So like I mentioned earlier, don't, it's here and it's on a video. You can stop it and you can stare at it, but it's just a skeleton. All the answers, you need to, everything you need is not here. You'll have to fill it in, but use your own good ideas. Just sort of try to take what I show you and see if you can use it to stimulate your own ideas. You need to own your own designs to be successful. So here are some members of this async task. Just a couple things to point out. Here is that life params that I referred to. So we're going to have an object of type life params. We're going to have a view that we're actually going to get from the life params, but we're going to have an object of type my grid view. You can probably figure out what that is. That's going to be the actual view where we're drawing the results. So when onDraw gets called, it's the onDraw for this grid view, my grid view. So this is a subclass of the view class, something you create. Number of rows, number of columns, and here, very important, two 2D arrays. As I mentioned earlier, I use char. You can use whatever you like. You want to use bool, many ways you could do this. Generation, that represents the current generation. Next generation is the generation I'm building as I iterate through the 2D array. Constructor here where I pass in these life params. So here's the async task framework. Here's on pre-execute. Here you want to do your setup. Now notice right away I use this life params. Life params contains a grid view object. So this is just for convenience. I mean, I could do this if I wanted every time I needed it. But I bring it out to its own member variable, really just for convenience and just to keep track of things a little bit better. The more code you write, the more features you add, the more difficult it gets to keep track of all the little pieces. Even if each individual piece is pretty simple, it can be very challenging sometimes to keep track of all of them. Here is our do in background method. So here, there's those life parameters. So, something to take note of here. So here are two booleans. They're called run and quit. These are set. The quit is set in your user interface, and it should be, just could be in your menu, could be a button, could be an overflow item, could be any number of things, but that's quit is on user command. Run is also on user command. Run is start game or what have you. So here we're going to do while not quit, and nested inside we're going to have another while loop, while run and not quit. The idea between here, this Boolean run is going to be true when the user can push run, but maybe the user can also push pause or stop. When the user selects pause or stop, run is false, so I don't want to go into this loop. However, I don't want to quit the game, so that's why I've got this nested loop structure. I quit the game when the user says quit. So while not quit. Then I go in here while run and not quit. And here I do the life rules. So here for int r equals 0, r less than number of rows, r plus plus. For int c equals 0, c less than number of rows, c plus plus. So here is where I'm going to move through the 2D array cell by cell. I'm going to check if I'm on an edge and bound my search area appropriately. Then I'm going to count the number of neighbors, and once I'm there, I'm home free. I count the number of neighbors, and when I'm moving through here, I'm moving through this 2D array. Now, when I count the neighbors and make a call on how this same cell is going to be populated in the next generation, I've got, not surprisingly, this 2D array of char called next generation. So I'm moving through the current 2D array, and I'm building the next as I go. I get through here, this nested loop. Now here, I'm going to do publish progress. So publish progress, next generation. Let's just go down and look what publish progress does. We're just going to update the grid, and there's some other things we have to do here, but here, this.mygridview.invalidate, this will cause on draw to be called. You need to come up with a way to set to pass this right here. You're going to come up with a way to pass that to your grid view so you can draw the right stuff when on draw is called. Remember here, this, the dot dot dot, means it can be a variable list of parameters. We only have one parameter, as is the case here. This, you can use values of 0 like it's an array. Here's your sleep between generations. Here's the life parameters dot get generation time. You need to put, and when you sleep, you need to put it in this try catch block for an interrupted exception. Now, there's lots of other things. I haven't, the UI. I leave that to you. Now, there's lots of other things. Many other things to do. But you can see, and I won't show you all this code. But here's a bare bones version. And you can see it's really not too much. There's a package that are utilities. So the way I do it in this life utils, I have a bunch of methods that ask, is it, the pseudocode we looked at, is top edge, is bottom edge, is left, is right. That's actually in this life utilities class. And neighbors, neighbors does, well, it's a class that does exactly what you think it does. It counts the number of neighbors I pass in a cell in a grid, and it counts the number of neighbors. Neighbors calls and makes use of these utilities. So you see, here's the async task, there's the parameters, there's the main activity. The main activity, looks, you wouldn't be surprised at all if you looked at it. And here is your grid view. This is an object, this is a class that extends the view class, just like we've talked about. So that's a possible program structure. I'm going to kind of fast forward here. This is some slides we looked at least one of them we looked at earlier. So just to sort of summarize, consider a 2D array for keeping track of your world. I'd say more than consider it. Use a 2D array, and additionally, use two 2D arrays, one for the current generation, one for the next generation. 2D arrays are row major. Remember what that means. That means that in the indices, the rows come first. Just a couple words about the game of life. It's the most frequently programmed computer game in existence. At least that's the claim from a number of journalists, tech journalists. How do we really know that? I'm not sure how they really know, but bottom line, it's very widely used. There's lots of code out there, and trust me, I've seen it all. have fun. Even, you know, even if you get into a little trouble here and there, have fun. Write your own code, please. Start simple. Use a glider. Use a known, known pattern with a known behavior. And note, you'll see other kinds of gliders. There's no central game of life authority per se. So this, note this glider is a little bit different than some of the other gliders that you'll see. It behaves the same. And the way you should attack this, build a working prototype, keep it simple, add complexity as you go. A couple quick references here. So I'm going to open one of these, but before I do that, just let me give you a word of advice. The game of life, whether or not it's true that it's the most frequently programmed thing ever, who knows? But boy, is there a lot out there. There is. There's a ton of stuff out there. Don't confuse yourself by trying to look at it all. Just pick one or two good. All you really need are one or two good references. And here are two good references. This is themath.com, where they've actually got the running Java applet. And actually, when we went over the rules, some of the graphics you saw there are right off of that site. I wanted to share with you this other site. And here, this is the, oops, let's see. I might have the wrong URL there. I might have the wrong URL there. So I'll fix this when I post the slides, but check this out. And there are a number of excellent worked examples in there. And for instance, what you will see are a number of simple patterns, and it'll take it through what happens after a couple of iterations. And this can really be your best friend sometimes. You need, before you can teach a computer to do this, you need to be able to do it yourself with a pen, a pen and a notepad. So take some simple patterns, work through them yourself, look at some of the pseudocode that I've given you, look through the structure, and once you sort of have a good strategy, good plan of attack, you'll be much more successful doing this than trying to sit down and do it, sort of willy-nilly. I don't really quite know what I'm going to do here, but I'll just write code and see what happens. It will take you can eventually get there that way, but it'll take you a lot longer and it won't be as good. So a little upfront thought will serve you well as you go down the road. So good luck. Hope you have fun with it.